In this week's Embedded Insiders, Rich is joined again by Zane Tsai, Director of the Platform Product Center at ADLINK Technology, to discuss how logistics companies are being affected by the race to deploy AI at the edge and insights for developers looking to increase the efficiency and productivity of logistics automation systems. The two are also joined by NVIDIA's Amit Goel, Director of Product Management for Embedded AI Platforms, who examines the complexities of integrating reliable performance into AI-based applications like independent automation. NVIDIA is currently building a hardware platform that will bring greater compute intelligence to autonomous systems at the edge. However, a solid software framework that can streamline the development, deployment, and management of the AI applications that will run on these devices. The company's Isaac SDK and DeepStream SDK for AI-based multi-sensor processing, video, audio, and image understanding are positioned to support these workloads across the engineering and operational lifecycles of AI-enabled robots. Finally, Tiara Oliver addresses the evolution of real-world AI this week. How do we transition from our historical lack of understanding about what's going on under the hood of complex neural networks and into an era of AI explainability around how these models operate? Will we ever be able to test, verify, and validate these workloads to the point that they can be heavily relied upon in safety-critical systems? Joanna Pingel and David Willingham, deep learning project managers at the Mathworks, believe we're already on our way.
Hello and welcome to the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and we're here with Rich Nass, the EVP and Brand Director of Embedded Computing Design. How are you today, Rich?
I'm good, and I've been thinking long and hard about this, and I have a new revenue stream for us.
Yes.
We are going to come up with NFT trading cards of you and me.
Trading cards?
Yes.
Are they going to be like pictures or are they going to be animated? I always liked the ones that I used to get trading cards where they would have drawings. You know, it wasn't the actual picture, but it would be a drawing of the player.
Well, I mean, we have the option to do whatever we want, but I thought, one might be in front of the keyboard. One could be in front of a Zoom station with a microphone, doing a video or a podcast or something like that. We could make megabucks with that.
Should I be like dunking a dev kit or something? We need action shots.
Hey, it's the wave of the future. Okay, we actually have some serious stuff to talk about. So.
Well, yeah, I mean, I was just going to say it's getting hot in here. Well, it's certainly getting hot in Japan, where Renesas recently had a fire at one of its chip manufacturing fabs. Did you hear about that?
Just recently, but do you know the extent of the damage?
Yeah, so apparently there were about 600 square meters of this fab that were destroyed. 5% of the building's clean room area. The whole building had to be shut down to allow for cleaning and reconstruction. The chips that were being manufactured there were actually headed for the automotive market. I'm reading here, Renesas is number 2 in the automotive chip market, controlling around 20% of global share in microcontrollers. It supplies Toyota and Nissan. No bueno. So that's going to cause a shortage in the supply there, which apparently is adding to a shrinkage in the availability of electronics for those applications, which is obviously not good news. And there's no good news to come out of this.
Yeah, I hate to say it, but these guys actually have some experience there. If you remember, God, I don't even know when it was. I'm going to say 8 years ago, but I'm probably way off, where they had an earthquake that shut down their fab for a while. And they scrambled pretty quickly and came up with some alternative means of producing these devices. I wonder if they're looking at the same thing.
Yeah, the earthquake is something that, that nobody can control. Here, apparently, the fire was caused by a surge, a power surge. And yeah, that's
It wasn't because people were smoking in the break room?
No smoking in the break room in the clean room. That's the smoking section is just off the clean
Okay.
room.
Yeah, I mean, we're hearing all about these shortages anyway, especially in automotive. And this, I was gonna say adds fuel to the fire, but I don't want to make light of this situation. I mean, it's definitely serious stuff.
Yeah.
Was anybody hurt?
No casualties,
Okay.
no
Well, that's the most
injuries,
important part.
for sure. One of the things that Renesas has really been working a lot towards with its automotive chips, and I don't believe these were the devices that were manufactured there, but I could be wrong. This is the Naka factory, Naka, for those who are interested in finding out more. We'll have some up on our website about it. But um, Renesas has been developing some of these bigger chips that are designed to carry artificial intelligence or run artificial intelligence workloads, on the car. Their R car series is designed for that and in vehicle infotainment stuff. So, hopefully that won't put a damper on those types of capabilities being delivered into the automobile, because we need devices like that out at the edge that are able to execute some machine learning functions and really get all of that data that we need, in from those sensors, process, analyze it, get it back up into the cloud, and start really refining those models so that we can make AI predictable enough and usable enough to be efficient and in these types of applications.
That was a really good segue, Brandon, because I just had a conversation with a couple of folks from NVIDIA and ADLINK, where we were talking about that subject specifically, AI at the edge, and they had a great perspective on it.
Rich is joined again by Zane Tsai, Director of the Platform Product Center at ADLINK Technology.
Good afternoon. My name is Rich Ness. I am the Executive Vice President of Open Systems Media, and I'm here for the second of 4 episodes that we're doing with ADLINK, where we're talking about some of the latest technologies that have to do with AI and at the edge, and the different things you have to do to accommodate that. We actually have a special guest today for this podcast, and that would be Amit Goel. But I'll introduce him in a second when we bring him in. We're going to start off with Zane Tsai, who you probably know from the first podcast. He heads the Platform Product Center of the Embedded Platform and Module Business Unit at ADLINK. But what we want to talk about today has to do with logistics and logistics automation. The e-commerce and retail industries are seeing exponential growth, and that puts a lot of pressure on the logistics industry. Logistics companies are relying on automation more than ever to increase productivity and efficiency. So I'll stop there and I'll ask Zane, what are the components that are needed by a vendor who wants to install a logistics automation system?
A logistic automation system is a fairly big system. So you can divide it into some small subsystems like conveying the goods or packaging the stuff. And in terms of components, there will be some robotic arms, the storage, also vision systems or data acquisition systems, subsystems that compose a middle system. Then finally, that comes a logistic automation system. So underlying there will be typically in a global management system. Sometimes they call it warehousing, execution system, subsystem, or warehousing management system. If we put it in other way to see that, if we have management a big fleet to distribute all the goods on the road, you need fleet management system, right? To dispatch all the tasks to each of the vehicles and the stuff. That's a similar idea for the logistics automation. So each parts are connected by the system. That's the way they dispatch the ordering or synchronize each other. But I have to say that's in traditional way, okay? And the more modern way is they're going to be distributed. And the reason they're going to be distributed is it's more likely to be more scalable. The traditional logistics automation tends to be building a big warehousing and the big shelves and to store all the goods in the rectangular space. And in that case, you need a big investment in the capex, and also you have to maintain the conveyor. You need to maintain all the robotics arms, or you have to hire a lot of operators to do the packaging. All this stuff are tightly connected, and they'll be supervised by the big system. But nowadays, the demands may change rapidly, and all the goods stored or all the type of the orderings are coming in a different way. Also, leveraging the advance of technology in AIs. So each of the subsystem units right now can have this intelligence. For example, do I really need a conveyor belt to move something from the shelf to the package? Or do I really need a pallet I put in on the ground and let all the operator do the job to move the goods from one place on the pallet? This can easily create some human error. So if you move the wrong goods to put on the pallet and you move it to the final destination, it's actually waste, because it data has to go there. It cannot be there because it's supposed to be in the other place. Not to mention, if you build the whole system in a big scale and for the conveyor belt, there's a single failure, then the whole process has to be stopped. So in a modern approach, in the distribution center or warehouse, they're going to use a lot of more self-control, or you say autonomous machines that control itself and decided what it's going to do. And for example, you take AMRs to replace the conveyor belt, and you take a smart pallet to replace an iterative of inspection from the operators, from the human errors. This kind of replacements are taking place right now by leveraging the technology of AI advance.
I think this is a good place to bring in our friend from NVIDIA. That would be Amit Goel. He's the Director of Product Management for autonomous machines. So Amit, the piece that NVIDIA brings, the compute part, is pretty complex today. And to integrate that in is not a simple process. You have to be able to talk to the imaging, to the storage. How do you do that in a seamless fashion?
Yeah, adding to what Zane was saying, right? The integration piece is extremely important as more and more of these independent automation systems are coming into the warehouse. And IoT, edge computing, and AI, these three things are playing a very pivotal role there. A simple example being, you don't need to communicate if the device that is going to go pick up a box and scan the barcode and check it against the inventory order, you can stop it right there if it's picking the wrong product, right? So we are building a platform that allows a wide variety of autonomous systems to share the same fabric, to have the same capabilities for edge computing and processing, so they can all be intelligent. And if you can distribute this intelligence across the different components of your warehouse, you can really make things work synergistically, which is not possible if you have a single compute infrastructure where it has to go there, and that's when you identify issues. That is definitely not a good idea for improving your productivity. And that's where using edge computing, using autonomous systems, and using artificial intelligence is helping these warehouses to automate things and make them much more productive.
I get that. And one of the parts that really scares me about this process is the software integration. You can have the best hardware out there, and you'd probably say that you do. But if you don't have the software to tie it all together, you don't really have a system. So when it comes to the software, what is the best place to start? Is this something that NVIDIA is deeply involved in, or is this something that ADLINK is supposed to be supplying, or is it a third party?
A Ferrari is not going to win you a Formula One race. You need a Michael Schumacher to go with it. And that's pretty much the same story for the hardware and software, right? We do some of the best hardware But in order to really extract the value out of that, you need a solid software platform to develop these end applications. And so what we are doing at NVIDIA is we are creating what we call these application-specific SDKs, which will enable customers to really easily develop these solutions. Consider warehouse automation. There are several pieces to it, as Zane mentioned, right? It could be as simple as just scanning the product to check whether it's the right thing that's there on the conveyor belt, and that could be done with a machine vision camera with AI capabilities. Or it could be an autonomous mobile robot that is going around the warehouse, planning path, avoiding obstacles, autonomously navigating. Or it could be a robotic arm that has to see what's there in the bin and pick it up and put it into the right box. So what we are doing is we're creating SDKs that will enable all of these applications. We have an SDK called DeepStream that allows developers to create applications for computer vision. So if you want to do optical inspection, or if you want to check the products that are coming in, or if you want to analyze what's happening in the warehouse, you can do that very easily with the DeepStream SDK. When it comes to robotics, we have another SDK called Isaac, which is a platform for building these robotic applications, control and perception applications, and AI for the mobile robots as well as for manipulation robots. So those are the things that we are doing, and using these tools now, the developers and end customers can really easily build their application. And because everything is running on the same platform, the integration becomes really easy. These things need to be continuously monitored and updated. And so we are bringing the cloud native technologies down to the edge, so people can easily manage these things, easily develop on this, and having a single platform allows them very easy integration.
What about the reliability of that system? Is that NVIDIA, or is that ADLINK?
The entire ecosystem has to come together to make things reliable, right? Of course, we are doing everything possible to make our software stack reliable, safe, secure. And also our hardware is designed to those standards for safety, security, and reliability. But as you can imagine, in a warehouse, there are so many different pieces that have to come together for a robotics and automation system. Our ecosystem partners like ADLINK provide some solutions that help with the reliability. And across the board, we need to work along with our ecosystem to make it a system that is reliable and easy to manage and maintain.
Yeah, I do agree, because NVIDIA, as their leading technology solution providers, they provide the state-of-the-art chip and software SDKs for us to do the integrations. So we also work to build the whole warehousing system. And it do require some field knowledge, and especially when you touch the actual scenarios, there will be different demands to solve. Some requirements to solve, some regulation, some environmental challenges, and some physical challenges. Those are challenges that are solving by us. We do see there's a great value that NVIDIA SDK is providing, and especially they're being synchronized by a single technology based on CUDA, including all those are training models, all the deployment of models, and all the execution or inferencing of utilizing these models are seamlessly running on all the platforms. So you can have a single backhaul to host all this knowledge and transform them into an actionable informations in these systems. I think that's the beauty of this. And also, when I mentioned about the challenges for the environment and the regulations, they will ask you some very specific questions about their specific demands. Sometimes for their regulatory stuff, some area they have a very specified certification to pass. The most of the regulations are defined in IEC or EN or ISO, but in some areas, like in China, they have a specific government requirements. That's some field demand you have to deal with, and when you do actually deploy the system. That's some field knowledge where we have been working with our end users or this warehousing system integrators for 20 years.
So one final question for you. A system like what we've been talking about here today would result in mountains of data. And a lot of times this has to be sorted through in real time. Is this a reality, and how do you deal with that?
We recently worked with a top 3 machinery vendors in Taiwan. They're actually this group. They utilize MRs, AGVs, or having all this machinery talking to each other to share information. And in that, we actually use a very specialized middleware to make sure the point-to-point communications can be complete and can be handled in a timely fashion. So the standard is called DDS. That's used in the military grade communication. Now we have utilized and make it available in factory automation, logistics automation area.
Amit, it's your subsystem that's creating all this data. Is that the right way to deal with it?
Yeah, absolutely. I think, when you start talking about data that's being collected by all the systems in a warehouse automation, they can be divided into 2 categories, right? There is the data that has to be acted immediately. An example of that is a robot that's going on a path to go pick up an object. If there's a pallet in front of it, it needs to react to it immediately. And so that it needs to process it and understand that, okay, this is a pallet, I need to go around it. Or if a person coming towards it, it needs to wait for it to get out of its way and then keep going, right? So there are those category of data that can be analyzed on the device, and then you don't need to transfer it, right? So you can just take the act on it right away, because that data is later not very useful for anything other than if you want to train a new neural network to detect those things. But for all practical purposes, you have to act on the data right there and then. Then there is the second data, which we call aggregated analytics data, right? Where all did this robot go, and where all did it see congestion next time, so that when we are planning the paths, what is the better path to do? Similarly, things like what is the orders that are coming in? Where are the things have to be kept together? At what time did we see that the throughput went down? So all of those data has to be then aggregated and analyzed for better efficiency. And for that, again, we have systems like Rapids and data science tools. When with the backend connected, it could be on the edge in the factory, or it could be in the cloud. You can then use this data, which is much less bandwidth compared to some of the computer vision data, which can be really high bandwidth. This analytics data can then be used for resource optimization, for better planning, and for improving productivity. And that's where the fabric that Zane was talking about can come into play. And how do you transfer this data in a secure and efficient way?
Finally, Tiara Oliver addresses the evolution of real-world AI this week. AI has been a hot topic in the engineering community for a few years now, but is still firmly positioned in the research and development domain. On the whole, there is still a gap in transitioning this tech from the lab into real-world contexts. Of course, the higher leverage the application or use case, the more difficult it is to move AI from the lab into the field. Most electronics require at least some degree of testing, verification, and validation, but by their very nature, most of the advanced AI models that have gained popularity in recent years are unpredictable. They are black boxes. Joanna Pingel, Deep Learning Project Manager at the Mathworks.
Since the beginning, AI has sort of been seen as a black box, where you have input data coming in, a model does something that you don't really understand, and then an output is produced with no real insight into why the model is choosing a certain result and how your training data influences the model as it trains. So ever since the beginning, people have been trying to uncover the black box nature of the AI model. A few years back, there were techniques developed to ask a model to produce an image of what it has learned. So tell me what you think a bicycle looks like. And then it would produce certain images to various degrees of success, of course. And sometimes the data would look exactly like a bicycle, and sometimes it wouldn't look like anything at all, but at least it was starting to give you insight into what the model was learning as it was training.
Unfortunately,
Various degrees of success.
just simply isn't good enough in a lot of systems. It certainly isn't good enough in real-time deterministic embedded systems, or any system that could be labeled safety critical.
AI is still at a place where there is a need to be able to explain exactly what the AI model is doing.
David Willingham in the Mathworks.
One way in which this can be done is to verify, validate, and test that model under a variety of scenarios in which it operates, and also when it's deployed into the field, make sure that it's still operating as it should, and making sure that if something awry was to happen, that appropriate actions are taken.
Historically, this would be where a standards body or bodies would step in. Entities like the International Standards Organization or the International Electrotechnical Committee are responsible for developing comprehensive standards and certification methodologies that would allow AI-based systems to be tested, verified, and validated in a repeatable, scalable manner that, in theory, would help the commercialization of AI take off. But the torrid pace of AI R&D, which seems to course correct almost on a monthly basis, has organizations playing catch-up.
Verification and validation and testing of AI-based systems is important in safety-critical systems. You could say it's critically important in safety-critical systems. So right now, all of those different industries and industry bodies are working on standards and certification methods that those who are building systems in those industries need to adhere to make sure that they can certify and validate that that system is acting as it should for the scenarios that it's being used in. The challenge is that not all of those standards bodies and committees have matured to a point which manufacturers and OEMs can now develop solutions to meet those standards. The standards just aren't quite there yet.
Currently, simulation is a leading approach for developers looking to get ahead with their AI-based embedded systems development. Tools like Mathworks Roadrunner, an environmental design and modeling tool that allows engineers to develop interactive 3D automated driving environments, combined with Simulink, which now supports AI blocks to create high-fidelity scenarios that encompass the gambit of interactions and environments an AI-based system might encounter in the real world. By conducting at least a portion of the testing, verification, and validation process in a software-based simulation environment, AI system developers could potentially save thousands of man-hours of testing time, as well as the cost that comes with it.
When we think about AI and AI residing in systems such as autonomous cars, there's so many scenarios in which that car could operate that you need to understand how that AI model will work. So right now, there are automotive companies driving around with their autonomous vehicles in the field to understand how these cars operate in various scenarios and real-world conditions. And that's quite a large effort taking place, thousands upon thousands and upon thousands of hours of these cars driving on the road to try and capture all of the different scenarios, some of them more frequent than others, some of them more isolated, so that they can make sure that AI is operating as it should in that particular system. But that presents a massive challenge, right? Right now, companies are physically going out into the field to test how these systems operate. What if all of these systems could be completely tested through a simulation environment? So having that same car run through the thousands upon thousands of hours of scenarios in a simulated environment so that the engineers can get that information that they require from that testing to understand if the AI is acting as it should. And so, this is a big area of development and investment, is having the ability to simulate these AIs within systems. I wouldn't say without the need for physical testing, but to aid or augment this physical testing so that when they do go in the field, we know that they're going to act as they should.
It's all well and good, but many engineering organizations aren't even that far along yet. A lot of these development teams are working on operational embedded functionality and domain-specific builds and are still working out where and how they source this AI into their systems. For the most part, these engineers are still asking, how do I integrate AI into my existing development cycle?
The AI piece adds a few other dimensions. AI models are now being deployed to the edge, they're being deployed to the cloud, they're being deployed to a combination of both of these systems. And so we have to augment some of these traditional engineering workflows with workflows that come from another area and operated traditionally different, such as from the IT space. And so with Mathworks, what we're doing is we're making sure that our users who are developing the engineering models they're used to are able to take these models and deploy them and integrate them into these newer systems or different systems than they're traditionally used to from IT.
Mathworks is enabling this by partnering with non-traditional partners for a physics-based simulation and modeling company. These include enterprise data science and MLOps solution provider Domino Data Lab, who offers an AI model lifecycle management platform, and a couple of other platforms you might have heard of called AWS and Microsoft Azure that now accept designs developed with Mathworks tools so they can reside along AI algorithms in a more native environment. These tech partnerships permit designs to be aligned across IT and OT development infrastructure that may exist within a development organization or with external collaborators so that AI functionality can be deployed on servers, edge devices, or both. Companies like Atlas Copco, the multinational industrial manufacturing equipment provider, are now leveraging these tool chains to develop digital twins that not only accelerate their testing, validation, and verification, but also serve as the foundation for advanced use cases like predictive maintenance on deployed real-world machinery.
What they've done is they use our software to develop a digital twin. So they build a digital or an AI model that represented some of these machines that they have deployed to these various plants around the world. And they wanted to make sure that they could test this model, this digital twin of this system with the different plants which these machines reside in around the world. In fact, they called out they've got over 120,000 of these particular machines that they've put sensors on that are connected to their servers. And they wanted to integrate this model with an IT system that enabled them to run this model along with the sensor data as it came in. By doing so, it enabled them to understand how their machines were operating, if they're operating as they should, as compared to the model, and if they needed to perform tasks such as maintenance in advance of a critical failure occurring.
All of this boils down to understanding AI more thoroughly so that it can be deployed with confidence in systems ranging from coffee machines to cars. But it's also helping explain and expose AI to non-data scientists and researchers, which will also help the technology proliferate.
AI is making its way into more and more applications. And so more and more opportunities to use deep learning and machine learning techniques as the technology improves. So engineers are learning what deep learning is and how to apply it to their application. And this opens up deep learning to new areas that were originally off limits, and maybe giving insight to people or to end users who are perhaps a little bit more adverse to AI by showing them why a model is choosing what it's choosing. This opens up explainability to even newer areas like safety critical systems, in which this is still a very active area of research and exploration, allowing AI to expand even further with that confidence in your model based on explainability.
Outside of the private sector, academic curriculums are evolving as well to improve the explainability of AI. So by the time the next generation of engineers and data scientists are on the job, we should be fluent in the language of explaining real-world AI systems.
A consequence of this research is that AI is now being taught at a lower level during undergraduate or postgraduate studies. So essentially, the next generation of engineers and scientists are being taught where and how AI can be used within their traditional engineering courses. And this is terminology where we've heard that the rise of the AI plus X course, where AI is integrated into some of these traditional models. For example, AI plus control theory.
If you're interested in learning how to speak AI, Mathworks developed training modules for reinforcement learning, deep learning, and machine learning, as well as a series on data science using MATLAB created in conjunction with Coursera. All of these can be accessed for free on the Mathworks website at mathworks.com.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.